So for our third day of the Volumes of Revolution discussion, we're going to be looking at hollow shapes. And in this first part, we're just looking at the general ideas and our overall approach to what is going on. So in these cases, we are going to have some kind of hollow shape. So it'll be a regular shape with a gap inside. How easily we can work this out will depend on what those shapes are. That kind of goes without saying, but it's worth saying anyway. So if we want the volume of the shaded region, we're going to be doing it like we did 2D problems. So you would have done a lot of problems in the quadratic equations unit where there are swimming pools or gardens or cases where you're going to be putting a border around something. And you had to figure out what is the area of that border. And they could say, well, we've got a swimming pool that's 10 meters wide and 8 meters long, and we're going to need a 2-meter safety perimeter around with a certain kind of tiling. What is the total area of the safety perimeter? Well, we'd add the 2 meters to each side. Sometimes it's not even 2 meters, sometimes it's X, and we want the area. So the area would be your 8 meters plus 2x times the 12 meters plus 2x. And then you work from here and solve for x, getting one positive root and a negative root, or something along those lines. You throw away the non-physical solution, and there you have your border. But the concept is still the same, where the area that you have, once you do this, you're going to have to subtract away the area of the inside, because that area, let me switch to the highlighter here, that would be the entire rectangle within that border. So then you'd want to subtract away the area that is contained within, because we wouldn't necessarily want to include this area here. So when we're finding our volumes, it's going to be a similar idea. There are times when you'll be able to find the volume of the complete outside shape and the complete inside shape and just subtract the two. Sometimes it is actually easier to do the combined shape together. So we will see exactly how that works, starting with our second video, using a worked example. I'm not going to worry about the examples where we're subtracting the two. You guys have done that more than enough in the quadratic equations unit to understand the concept. That's really just two volumes. So I'm going to be focusing on ones where it is in fact easier to deal with the combined shape than the original.